Hello viewers, I'm here again under the umbrella of the Zoological Society of Assam. Today's presentation is dating of fossils. This is a back-to-back topic with my last presentation, that is fossils, and I think this presentation will not only be beneficial to the undergraduate zoology students, but then it will be helpful for those who are studying the allied sciences like anthropology and geology. Moreover, it will also be helpful to those students who are preparing for competitive examination. I dedicate this piece of presentation to the student fraternity with whom I have been in contact over the years. So friends, before we proceed to our topic, let me tell you what you will be knowing at the end of the presentation. You'll be knowing what is dating of fossils, the related terminologies. Whenever I come through new words, I always tell you the meanings. Then we'll go to the methods of dating fossils, then the radiometric dating in details, then a little bit about the bracketing of fossils, the carbon-14 dating, then the other dating methods like the lead dating, potassium dating, etc. Then we'll go to the, of course, it's my signature, the mind map, and then the sample questions. Now viewers, whenever I start a topic, I want my viewers to know a little bit about the history, to make it more interesting. Nothing to do with much of academics, but then, looking at the picture will make you remember things at the end of the day. He is a person whom we know as the father of paleontology, and he is George Cuvier. Now, George Cuvier joined the fledgling National Museum way back in 1795, and quickly he became an expert on the study of the anatomy of animals. And then, with this knowledge in hand, he tried to interpret fossils with unprecedented insight. Legend says that he sometimes, with a few fragments of bones, he used to very efficiently reconstruct the complete anatomy of a previously unknown species with simple, uncanny accuracy. Now viewers, as we know the dates of our births or deaths, whatever, similarly, scientists also try to know the dates of the fossils so that we can reconstruct the animal kingdom and say which animal existed when. So this is known as dating of fossils. And broadly speaking, we have two methods of dating fossils. The first method is known as the relative dating. The second method is known as the absolute dating. Now, in relative dating, it is in relation or in relativeness with something else. And absolute dating is when you have the exact information about the fossils. Coming to the relative dating, this is used to determine a fossil's approximate age by comparing it to similar rocks and fossils of known ages. Now this is not a very accurate method, but still when the animal is soft or when the animal is not to be seen as a fossil, this is a method which comes to rescue. Absolute dating is used to determine a precise age of a fossil by using radiometric dating to measure the decay of isotopes either within the fossil or more often the rocks associated with it. Now later on we will come to what is a radiometric dating. Now friends, before going to the first method, that is the relative method of dating fossils, we have to know what are index fossils. Now index fossils are also known as guide fossils or indicator fossils, and these are fossils used to define and identify geologic periods or faunal stages. These fossils can be defined as commonly found, widely distributed fossils that are limited in time span. Now, if one finds an index fossil in a given layer, then one can have an idea on the age of the layer. That means we can learn about the strata of the rock. That means stratigraphy, or the study of rocks and its relation to which geological time scale it occurs, is very easily known when we study through the index fossils. Now, the scientists can use certain types of fossils referred to as index fossils. Just now I told you what are index fossils, and these index fossils will help to assist in relative dating via correlation. Relative dating via correlation. Now index fossils are fossils that are known to occur only within a very specific age range. Typically commonly occurring fossils that has a widespread geographic distribution, such as brachiopods, trilobites and ammonites, work best as index fossils. Of course, in the marine environment, the protists are very good index fossils. Now, if the fossils that we are trying to date occurs alongside with one of these index fossils, then the fossils that we are about to date must fall into the age range of the index fossils. And it is not necessary to date the fossils once again, because we already know the index fossils and in which age they occur. So the fossils that is in question need not be dated. So in a conclusion, we can say that fossils that are found in undisturbed sedimentary rocks and in short geological time period generally lie in recognizable strata of older rocks below and subsequently form layers above. Based on the presence of such fossils in rocks, the age of other fossils in the same rock can be determined without dating, because such fossils are an index to a particular geological period. So friends, now you know why index fossils are that important, because they are characteristic of a given layer in the stratigraphy. They are widely used to study the biostratigraphy. And can we just record the three characteristics of an index fossil? Yes. The fossilized organism must be easily recognizable, it must be easy to identify, and it should look unique. And these fossils have to be geographically widespread or found over large areas, so that we can use them to match layers separated by huge distances. Now, in the terrestrial areas, the ammonites are considered good index fossils. As why? Because different species represent specific geologic periods in rocks. So in a nutshell, when you study fossils or when you date fossils using the relative dating method, you have to know what are index fossils and how these can be used to study the stratigraphy, and how the stratigraphy makes it possible to date the other fossils by knowing the index fossils. And it becomes easier, because if this remain in the same time age, then it is not necessary to date the fossils that you have in hand, because the index fossils will guide you to know the age of the fossils in question. Now viewers, let us very quickly go over this slide. This is a picture of a trilobite, and we talked about index fossils. Sometimes it so happens that we have to use multiple index fossils to date a fossil. Suppose in a hypothetical example, if we consider a rock formation that contains fossils of a type of brachiopod known to occur between 410 and 420 MY, and the same rock formation also contains a type of trilobite that was known to live 415 to 425 MY. Now, since the rock formation contains both types of fossils, mathematically this is very simple, that the age of the rock formation must be in the overlapping date, that is from 415 to 420 MY. Very simple. So this is a method when we use multiple index fossils for dating of the fossils, and we should know how this overlapping can be measured. Now quickly going to the very small concept of fossil succession, I want to go to the history of that, a little bit into the history. Way back in 1793, there was a land surveyor named William Spink. Now, he worked in southern England and he studied all kinds of different rock strata that was exposed to in the outcrops and the canals. And then he collected fossils from his work sites. He learned to recognize which fossils tend to show up in which rock strata. Then he began to identify rock layers by the fossils they contain, and he even noticed that the general order of the strata was identical over many different parts of the country. So different parts of the country had the same type of rock strata in a nutshell. So he was the first person to understand the principle of fossil succession. Fossil succession is based on the observation that certain assemblages or groups of animals and plants have lived during certain time periods over geologic history. For example, human beings and modern elephants are part of the same assemblage because we live in the same period. Therefore, we can use the succession of fossil assemblages sometimes to establish the relative ages of rocks. Now friends, we come to the second method of dating of fossils, which we term as radioactive dating. Now in the picture you can see how the radioactive carbon decays at a known rate. Now this radioactive carbon 14 is an unstable element which tries to come to the normal form by its decay. Now if you take a small piece of the fossil that is burned, it gets converted to carbon dioxide gas, and you will see that some part will become carbon 12 and some part will become carbon 14. Now this carbon 14 as an isotope is unstable, which tends to become carbon 12 or carbon 13 because carbon has 3 isotopes. I think you know what is an isotope. The isotope is different forms of the same element where the proton number will be the same, the neutron number will be different. And this carbon 14 will decay into nitrogen 14 emitting an electron, and this ultimately can be recorded in a counter. So if we try to precisely tell about absolute dating, that is the second method of dating of fossils, we may say that it is used to determine the precise age of a rock or fossil through radiometric dating methods. Now this radiometric dating methods will involve the use of the decay of carbon that is specifically used as a clock to record the age of a fossil. It uses the radioactive minerals, maybe carbon, maybe something else, that occur in the rocks and fossils, almost like a geological clock. We use radioactive carbon because carbon is a very constituent part of any living body. It is often much easier to date volcanic rocks than the fossils themselves or the sedimentary rocks than they are found in, because sedimentary rocks, the dating is possible only to a certain age, because the carbon decay method can be aged only up to 60,000 years. So often the layers of the volcanic rocks above and below the layers that contain the fossils can be dated to provide a date range for the fossil containing rocks. So in a very nutshell, you can say that these isotopes, now isotopes again, I am confirming that isotopes are atoms in some chemical elements which have different forms. These isotopes will break down at a constant rate over time through the method of radioactive decay. Now by measuring the ratio of the original, which we say as parent isotope, to the amount of the daughter isotope, that breaks down into an age which can be determined, and thereby the fossil age also can be determined. So we can say that absolute dating will provide the chronological estimates of the age of geologic materials associated with the fossils. So friends, let us go a little bit deeper into the radiometric dating method, or which we say as the radioactive clock method. This was a device which was first introduced by Boltwood in 1907 and later by Rutherford in 1955. It is based on the rate of disintegration of the radioactive material, which is always constant, and it is not affected by environmental factors. Now, the time taken by 50% of the radioactive material to disintegrate into stable element is known as its half-life. Now, this half-life as a definition I'll be putting in a later slide, which may help you to answer some one-mark question. If we know the half-life of an element, then the age of the fossil can be calculated. How? By finding out the ratio of the radioactive element and its daughter, the stable daughter element, using the scintillation counter or the Geiger-Müller counter. Now here in the diagram you will see this is a technique used to date the materials such as rocks using radioactive materials contained in the rocks or fossils. And here we have taken the example of carbon-14, which is an unstable element. It is an isotope of carbon. The exact age can then help us with some aspects of relative dating also. So relative dating and absolute dating are always, complementary to each other. So here you can see the constant rate of disintegration of carbon-14. On the x-axis you will see the number of half-life, and on the y-axis you will find the remaining carbon-14. So with this data you will be able to know the rate of disintegration of carbon and as well as to find out the age of the rock. Now this is a very very traditional method of dating of fossils, which is known as absolute dating. Nowadays, of course, there are other methods of dating. You can do that by beta counting devices, which counts the number of beta radiation emitted by the decaying C14 atoms in a sample. Then more recently there are other methods of accelerator mass spectrometry, which has become the methods of choice. And of course now in this computer related age, we have the software for putting the data and finding down the age of the rock. Now friends, before going more into carbon dating of fossils, let me bring into you a new concept known as bracketing fossils. Now we all know that the universe is full of naturally occurring radioactive elements. Now these radioactive atoms, as I already told you, they are very unstable, and over time these radioactive parent atoms they will decay into stable daughter atoms. When molten rocks cool, they will form what we know as igneous rocks. Here we will find the radioactive atoms being trapped inside. Afterwards, what happens? They will decay at a predictable rate. All radioactive atoms will have a predictable rate of decay. So by measuring the quantity of unstable atoms left in the rock and comparing it to the quantity of stable daughter atoms in the rock, the scientists are able to estimate the amount of time that has passed since that rock had formed. In other words, we say that the fossils are generally found in sedimentary rocks because the conditions of fossilization, as I explained in my previous lecture, they are more suitable for the sedimentary rocks, not the igneous rocks. Now, sedimentary rocks can be dated using the radioactive carbon, but because carbon decays relatively quickly, this will only work for rocks younger than about 50,000 years. So, in order to date the more older fossils, the scientists brought up this concept of bracketing fossils, wherein they look for layers of igneous rocks or volcanic ash above and below the fossil that they want to study. The scientists will then date the igneous rocks using the elements that are slow to decay in comparison to carbon, such as the dating of uranium and potassium. By dating these surrounding layers, they can figure out the youngest and the oldest that the fossil might be, and this is known as the bracketing of fossils, and it helps us to know the age of the sedimentary layer in which the fossils occur. So friends, at the beginning of this lecture I told you that this presentation is also meant for allied sciences like anthropology or geology. So before knowing or before going into the concept of dating, you always have to know what is a half-life. And you may get a question of about 1 or 2 marks as to what a half-life of an element is. So if we want to define half-life, it is the time required for a quantity to fall to half of its starting value. So you might say that the full life of a radioactive isotope ends when it has given off all of its radiation and reaches a point of being non-radioactive. So when the isotope is halfway to that point, it has reached its half-life, and it is the half-life that is important to us when we consider dating of fossils. And I told you that carbon-14 dating is a classic example of absolute dating of fossils. Throwing into the history of carbon dating, I will want to give you some inputs as to who brought this concept of carbon-14 dating. It was way back in 1946, Willard Libby proposed an innovative method for dating organic materials by measuring their content of carbon-14, which was a newly discovered radioactive isotope of carbon. Known as radiocarbon dating, this method provides the objective age estimates for carbon-based objects that originated from living organisms, because we all know that carbon is a constituent of living organisms. The radiocarbon revolution, made possible by Libby's discovery, greatly benefited the fields of archaeology and geology by allowing practitioners to develop more precise historical chronologies across geography and other cultures. And of course, in the science of chemistry, he was awarded the Nobel Prize later on. So friends, let us summarize on the concept of carbon dating by knowing some of the facts of this principle of carbon-14 dating. We all know that as soon as a living organism dies, it stops taking in new carbon. You know why? Because the tissues are no longer living and there is no incorporation of additional or new carbon. The ratio of carbon-12 to carbon-14 at the moment of death is the same as every other living thing. But the carbon-14 decays and it is not replaced. The carbon-14 decays with its half-life of 5,700 years. Actually, it is around 5,730 years, but then we approximately say that it is 5,700 years, while the amount of carbon-12 remains constant in the sample, because carbon-12 is stable. Now, by looking at the ratio of carbon-12 to carbon-14 in the sample and comparing it to the ratio in a living organism, it is possible to determine the age of a formerly living thing very precisely. Now, there is a very simple formula to calculate how old the sample is by carbon-14 dating. And this is the formula: the log of NF by N0 divided by minus 0.693 whole brackets into T half, that is the half-life, and minus 0.693 is the rate of decay of carbon-14. Now, if we have a fossil that had 10% carbon-14 compared to a living sample, so this is the ratio. So 10% is the comparison of carbon-14 to a living sample. That means comparison of the fossil carbon-14 to a living carbon-14 sample. So this is, suppose we say it is 10%. So you place it in the formula. So 10% will be definitely 0.10, and then we have the minus 0.693 as the decaying rate of carbon-14 into what we say already calculated half-life is 5,700 years, and when you do the calculation we find that the fossil is about 18,940 years old. So I think you are very clear on this concept of carbon dating by now. So viewers, carbon-14 dating method of fossils was a very traditional method when we studied absolute dating of fossils. As of now, there are other methods which have come into focus, and these methods, of course, they have shown very good results, and we are able to date even older fossils than we can do with carbon-14 dating. Now, these are uranium lead dating, potassium argon and rubidium strontium dating, and of course there are other methods, but we are going to confine in these two methods. So we know that since the half-life of carbon-14 is 5,700 years approximately, it is reliable to date the objects only up to about 60,000 years old. However, the principle of carbon-14 dating applies to other isotopes as well, as just now I told you. The same principle of carbon-14 dating can be applied to other isotopes as well. For example, potassium-40 is another radioactive element which is naturally found in our body, and this has a half-life of 1.3 billion years. So you know, with this method we are able to trace fossils even earlier to what we can do with carbon-14 dating. About that, other useful radioisotopes for radioactive dating include the uranium-235 dating, which has a half-life of 704 million years, and thorium-232, where half-life is 14 billion years, and rubidium-87, having a half-life of 49 billion years. So at the present moment, carbon-14 dating is not the only method of dating fossils when we go to absolute dating of fossils. But then carbon-14 dating is known as the classic example of absolute dating of fossils. Now friends, I mentioned about the other methods apart from carbon-14 dating in the absolute dating of fossil category. And here a question will crop up in your mind as to what edge does these methods have over the carbon-14 dating method, or why is it necessary? So let us have a quick glance into the uranium-lead dating. We all know that uranium is an unstable element and it has a tendency to become, as like other isotopes, it has a tendency to become stable, and when it becomes stable, it changes into lead. Now, this can be used to find the age of a uranium-containing mineral. It works because we know that the radioactive decay rates of uranium-238, which decays to lead-206, and for uranium-235, it decays to lead-207. So, we start out with these two isotopes of uranium that are unstable and radioactive. They release radiation until they eventually become stable isotopes of lead. These two uranium isotopes decay at different rates. Point to be noted, they decay at different rates. In other words, they have different half-lives. The half-life of uranium-238 to lead-206 is 4.47 billion years. On the other hand, the uranium-235, which becomes lead-207, this is marked by a half-life of 704 million years. Now, these differing rates of decay help make uranium-lead dating one of the most reliable methods of radiometric dating because they provide two different decay clocks, and this provides a built-in cross-check to more accurately determine the age of the sample. Am I clear? Yes, friends. Another question. What about potassium-argon and rubidium-strontium dating? This question will crop up in your mind. Uranium is not the only isotope that can be used to date rocks. We see additional methods of radiometric dating based on the decay of different other isotopes. For example, with potassium-argon dating, we can tell the age of materials that contain potassium because we know that potassium-40 decays into argon-40, and has a half-life of 1.3 billion years. And then with rubidium-strontium dating, we see that rubidium-87 decays into strontium-87 and has a half-life of 50 billion years. By anyone's standards, 50 billion years is a long time. In fact, this form of dating has been used to date the age of rocks brought back to Earth from the Moon. So, from the fossils point of view, maybe radioactive carbon dating is very important, but if we want to date other minerals or other materials containing, suppose, potassium, rubidium, or maybe uranium, then these are the methods which are foolproof. Okay? So friends, at the end of the topic, I have a piece of advice for you. Kindly go through this mind map so that it is easier for you to remember the chapter as well as take the points easily into your mind when you go for your examination. Viewers, these are some chosen sample questions. By answering these questions, you will be able to recapitulate the topic very easily. You will for sure go through your books that are given in your syllabus, but then these suggested readings will help you to gather more knowledge on the topic. A very warm thanks, viewers, for your patient hearing, and you can catch me on these 2 mails for any feedback. A hearty acknowledgement and a very big thanks to the Zoological Society of Assam. Stay tuned.